Today's episode is called The Loop. What ReAct actually is. The load-bearing element isn't the thought, it's the observation. So sometimes in meetings you hear someone say, we built a React agent. And usually people say that as if they built a firewall or bought a firewall or they're secure now. Here is what actually they built. They built a loop, and it's coming from a 2022 paper. The idea here, if you strip it down, is that you have think, act, observe. These amber dashed lines here are basically saying it's the model that's going to decide the transition, not the code. So it can go from observe to act or think. It's the model for the model to decide. The only thing that still is controlled by code here is this part. Like the whole box is this part while not done and steps below the limit. So hold on to that because that's something we're going to be talking about soon, and it's very important here. Notice the progression. So we started with workflows, then we started speaking about features. Step by step, we have been going from workflows and to more agentic patterns. And today, ReAct is a progression more towards that more agentic structure. So let's first look at an example. So here you have purchase order mismatch from the previous episodes. So let's look at the trace and we will see how the mechanics will look like. So here we have the invoice total exceeding the PO. That's the thought, the PO total. That's an issue, right? So total by, you have the difference at 640, okay? So check quantities first. This action comes. So thought, the model says, okay, you need to go action, you need to check, read the purchase order, and then after reading the purchase order, you're gonna have an observation, and the observation says, the PO says quantity 10. Okay, life is good. Second lap, you have the thought. The thought says, okay, the invoice says 12, so this is either over delivery or over billing. So you have the PO, purchase order, and the invoice, there is a mismatch between them. And you need to investigate, right? Check what arrived to know if it's over delivery or over billing. So action, what you need to do is read the goods receipts. You go and you read the POs. After that, you're going to be like, okay, we have this information here, we have the information here, and we are here. And now the final observation. The observation is that 2 receipts, 2 plus 10, so 10 plus 2, and the second one is dated after the PO was changed. So what this says is that you have 2 laps. The second observation contradicted the first plan, so the next thought is a different plan. So here you're having a different plan. And nothing in my code actually decided that. So we came out and we found out that the second day, like the issue was the dating of the PO change, and that created these issues of the receipts. So there is no branch anywhere that says that if the receipts are late, you need to do this. If we took early examples in our series, we would say, like, here the gate is being created by our model. Everything is decided by our model. What would be the next steps? And there are 3 kinds of line here. We have the context, the action, and the observation. Action lines basically are interactions with databases touching the world, basically. Thoughts, you only write into the context. You're writing what's the context. Observation lines are the world, or after an action, you're sort of, the world is answering back. So these are different mechanisms, of course. Next step would be what is actually thought here. What could be considered thought. So here, how would you define an action? And this was actually written in the paper. So the way they would define an action is that it's the tools plus the thought. So, and that would create the action. There is nothing, it's nothing special at the end of the day. So this is how it would look like. You have your action, which would ask from the world. The world could be an API, it would do a GET request or whatever, and then you would return your answer as tokens. And that's the observation. And the action then is done with the thought. So the only difference here is that the thought just interacts with the context, nothing, no API from the outside, no interaction with the outside world, just the current context, and you would use the thought, which doesn't mean this is useless, but and that actually it could be smart to do it because it costs less, it's less reliant on external elements. So the thought in itself is not a bad thing, but you need to have a perspective and understand what's the action here. So basically, this is how we would define it. A thought does not affect the external environment, thus leading to no observation feedback. It's the model talking to itself before choosing its real move. And this is from the paper ReAct that was published in ICLR 2023. So now, this is the main idea why the ReAct loop actually works. So let's say you don't do the API calls, or it's not made in that circular idea in mind. So let's make it this way, for example. The problem is, if you have a mistake in the thought without any outside calls, the mistake would actually escalate. We have seen this before in at least two modes, for example. If you have too many steps, or you have any time you have a tree structure, like something that looks like a tree and it goes out to branches, every time that increases the issues of, like, the chance of having a problem or a mistake that was done early on escalating. So the idea is to always try to introduce context at every step, which is actually here easier said than done, because first, you don't know what context should be introduced to correct this mistake. So here, you as an engineer would need to, in a way, think about, okay, every step or what would be the conditions that would make me trigger this context pulling. And that's very important. So here, by definition, you would say what the loop actually buys you is not better thinking. It is reality interrupting the reasoning at every step. And it is stranger than the gate that we already have seen in previous examples. A gate was basically our code check and output between steps. And basically the code shows, and observation feels the model's own choice inside the control flow. So it's the model that decides to make this. But even then, you as an engineer, you need to put the model, or give enough of context to the model to make the correct choice here. Because this is really fine engineering task. It's not something that you can just vibe code, really. So yeah, that's the idea. Now let's have a quick look at the numbers. So in reasoning tasks alone, actually, if you have plain step-by-step reasoning, you would score actually higher than using the ReAct loop, which is amazing, of course. And on reasoning alone, with fact-checking, you would get a lower score. So now you would ask the question, so if it's on its own paper, on question answering, plain step-by-step is reasoning beat the loop. So why would anyone, basically also the famous agent pattern, lost on raw accuracy? So it won on fact-checking, where the answer depended on going and looking something up, but it didn't win on the reasoning. So why would anyone use it, Why wouldn't we? Because the scores even here are close. Like it's not that much of a difference. And you don't know in the beginning, maybe the task could be just reasoning, or the task could be fact-checking with reasoning. So why would anyone basically use it if it costs more? Because the loop, you're basically costing more latency and tokens and spending more. And so what's the point? The researchers went back and dissected the failures. So this is the part where everyone needs to focus. Of the cases where pure reasoning failed, you have 56% were, for reasoning alone, 56% were invented facts. So basically hallucinations. And this is a big, big problem, of course, if you have hallucinations. On the other side, for the loop, it was 0%. 0% of the failures were hallucinations. So this brings so much stability to a bigger system, or a system where you need reliability, of course. Of the successes, how many were lucky hallucinations? Right answer, but invented the reason. So for reasoning, it was about 14%, 1 in 7. And for the loop, it was about 6%. And so these results are actually amazing, especially this part of the hallucination. But generally, and this is coming from the researchers themselves, they said the best way to do this is to do switching. So you run the loop, and if it doesn't finish in a few steps, you fall back to reasoning. At this percentage, like 35.1%, you would be running the loop. At 64.6%, basically 2/3, you'd be switching to reasoning alone. And one caveat about this is that these percentages come from the authors basically and like sampling and hand labeling the trajectories, not from scoring the whole benchmark. So here is what you can now predict, which is the whole point of the loop, is that this loop will buy you groundedness. And this groundedness can be broken down in 3 things. First of all, you have how anchored your retrieved reality or your context is, and it's not just hallucination or it sounds right, which is really good in production. Second is like the fact that failures are visible. So when it fails, if there is an issue, your model will tell you that there is a problem, so which is really nice. It will never hallucinate that it's actually all right or it's confident about its answer. It will give you a real failure. And adaptability. That means it can change plan mid-task because, as we have seen already, you have a loop and another loop, and the plan of the second one could be different from this one. And this now gives you 2 cases. First, if the task is inside your model, basically summarize, write, classify, derive from what is already known. You just use plain reasoning. It's a lot cheaper, it's a lot faster, and actually it is actually better for this task. On the other side, if you need to check real life data and, for example, you need to look up the PO, read receipts, whatever thing out there that needs groundedness with real life, then the loop ReAct is the way to go. So you're not choosing between right and wrong, you are choosing what kind of wrong you can afford, which might not be glamorous, but it is actually really, really nice to have a loud failure than a silent one in production context. Especially that 0% on the hallucination is worth its weight in gold. As I said here, a hallucination you can't see is worse than a failure you can. That is the entire trait. So now the part we actually build a ReAct agent. The issue that was reported by the authors of the paper is that the model repetitively generates the previous thoughts and actions. So you can actually, even if you ground it or you do something, it's still too reliant on previous thoughts and actions. So even the second plan may be too reliant on those. So it might be stuck in the loop. So every time it's just looping and not incrementing or changing the plan enough between one loop and another. So how would you deal with that? Actually, LangGraph sets a recursion limit of 25, for example, on these loops, and that counts graph steps, not model calls. So the OpenAI agent SDK raises the exception. Here, like, this is basically what it does. When max turns is exceeded, you define what is max turns. That navy rectangle that you have in front of you from slide 1 that we have discussed. Remember, like below certain threshold of steps is the only guarantee thing to make sure that the loop terminates. And you already know from the production data that real deployments keep loops under 10 steps. Now you know the deeper reason. It's not basically that they don't want to spend more money or anything. It's just that an uncapped loop is an unbounded liability. It actually can do whatever it wants. There are many issues that happen because there were no capped loops. So yeah, cap your loop. So early on I told you it's not just about cost, but it is actually also about cost. So if we look between every lap needs to check the context of the previous ones, as you can see here. And you can actually see how the cost per lap is actually rising. Per loop, it's actually really, really rising. So here at step number 20, you're actually paying for the 20 plus ones, which is a lot per cost per token. And this mechanism behind the token multiplier you already know, which is loops rebuy their own history every lap. This is something we have been talking about in all of the episodes of the series. So yeah, as here there is a remark, mechanical, not measured figure. Every turn we send the full history to a stateless API. Bars are illustrative growth, not benchmark data. So yeah, it's not really measurements. These are just a representation. So the current 2026 status in 2 rows. Basically, the top row is the format. Those explicit thought column lines that you see here, what we see is that the thought is basically, that you have here, is basically fading, and no one is currently using it. The reason is that it got absorbed. So reasoning models, currently, if you see Claude, ChatGPT, or whatever, natively do it without you telling it to prompt it. So you don't need to do it externally or added by you. And current models think natively between tool calls. So you don't need, as I told you, you don't need to do it additionally. The bottom row is the structure. And here we can see that actually, if you look at the current projects, it's actually, they're still using formats that look like the ReAct loop or very similar steps, especially in shipping and production. It brings a lot of stability to your agents. Now, one honest note to carry with this, the visible trace is not a faithful window into what the model actually computed. Stated reasoning can misrepresent the real reason for an answer. What does that mean? So the visible trace is not a faithful window in what the model actually computed. It's the auditing can create problems. Like if you ask your model to create audit logs, you might not end up with good auditing for your whatever auditing task that you have upcoming. So for governance, I would still ask you to use process mining because that's the best auditing tool we have today. So to recap, these are the elements that we have seen today. I don't need to reread them for you. After that, for next episode, we will see 2 variants, one where you introducing critique at the think step and one without the observe part in our ReAct loop. So that was it for today's episode. If you liked the content, please like and subscribe and follow me on LinkedIn. Thank you.